All right, everybody, I think we'll go ahead and get started. My name is Chris Reisner, and this session is developing iOS and Android apps with Windows Azure Mobile Services. Just to kind of start things off, I'll tell you a little bit about myself. I'm a Windows Azure technical evangelist for Microsoft, so I focus specifically on connecting Windows Azure to mobile devices, and even more so specifically on the iOS and Android side of things. Before working at Microsoft, which was relatively recent, I just started last year, I was living in Michigan, and there I founded the Detroit Google Developer Group, and now that I live in Washington, I'm actually a co-founder of the Seattle Google Developer Group. And then in my free time, I like to do, Pacific Northwest-y type things like go sailing and hiking and, that typical stuff. So today we're going to talk about some options for iOS and Android development. I'm going to pull you guys in a second to kind of see who's doing what, but if you don't know, there's a few different options you have when it comes to actually developing apps for iOS and Android. We're then going to move into talking about building with mobile services, and then we'll talk about some of the features, which it's a clear giveaway. We're going to talk about data storage, push notifications, security and authentication. And then at the end, we should have ample time for any questions, so save those for the end because I might cover it throughout the session. So how do you develop for iOS and Android? How many of you today are actively developing for iOS or Android? Wow. When they said I could do a session here about developing iOS and Android apps at TechEd, I really thought they were kidding. So it's cool to see so many people actually come to the session that are actively doing it. There's a couple different options, and we're going to talk about 3 different ways of developing apps for iOS and Android. There's the native option, which is kind of the way I don't want to say the natural way, but the way a lot of people do it, which is to use Objective-C for iOS and Java for Android. There's the PhoneGap/Cordova type solution where essentially you're kind of embedding a website into a native application. So you really do the app development in HTML and JavaScript and CSS. And then there's something from a company called Xamarin, which it's really an open source framework called Mono, but they make MonoTouch and MonoDroid, which allows you to develop Android and iOS apps using C#. So really quickly, how many people are doing native development today? Okay. How many people are doing PhoneGap style? A couple fewer. And then how many people are playing with Mono? All right, I think actually more Mono than PhoneGap. That's impressive. Well, we're actually going to see a few demos from each of these, so you're kind of going to get a little flavor of how each works. And the plus side to all these is that they're all going to work with mobile services. The one question I'm really not going to address in this session is which one of these you should use, because that's a religious argument that we could talk about for the rest of the week. So like I said, they can all use mobile services. So if you haven't seen it before, mobile services is essentially a backend as a service. The idea being that instead of having to code and test and deploy and then maintain your service, whether it's in a service layer in like something like websites or in cloud services or anywhere else, you basically spin it up and then you can just connect your applications to it with getting a ton of features that most mobile applications want or need, but you don't have to worry about figuring them all out. So with mobile services, you get stuff like data storage powered by SQL database, push notifications, and that's cross-platform for pretty much every platform that's supported by mobile services. Both user authentication and data authorization. Custom server-side logic, the idea being, of course, that there's no way I could figure out what kind of application you might want to build and then what you need to do on the server side, so you get the ability to customize that. Scaling, so like anything else in the cloud, you should have the ability to scale up and scale out. Logging and diagnostics, so insight into how your application is performing. And then the scheduler, which is kind of like doing back-end job processing. And again, all these features, which we're going to see pretty much all of these today, they all work no matter how you're going to make your app for iOS or Android. So the first thing we're going to do is we're going to go kind of through a getting started, and we're going to look at actually putting an application into iOS using PhoneGap. So first thing I'm going to do is I've already downloaded the PhoneGap tools, which you just do from PhoneGap.com, and I get some scripts that I can use to create a new iOS project. So here I'm just going to create a TechEd is Awesome project. It's created, so I'll go ahead and open that up. So let's go ahead and run this and see what it does, and then we'll kind of look at how the code for PhoneGap works. So this is very simple. All it does is it starts up, and then once the application is ready, it just says device is ready. The interesting thing about PhoneGap is, again, it's basically embedding a website into your native application. So there's all this stuff right here which kind of wraps the talking from my HTML JavaScript app to the underlying hardware layer. But all I really need to focus on, and all you do need to focus on when you're making one of these style apps, is what's in this www folder, which is the HTML, the JavaScript, and the CSS. Now, the HTML file is pretty simple here, nothing all that impressive except for the fact that it includes some JavaScript files. If we hop over to the JavaScript file, though, this is kind of where everything important happens and where you do really all the logic for your application. All we're going to look at here, for now at least, is the device ready event. So before you can actually do anything with the native device capabilities from your PhoneGap app, you have to have received this device ready event. So here it's not doing anything until it gets that event. And what we're going to do is we're going to take a mobile services application, embed it in here, and all of our functionality we're going to also drop into this received event. So let's go over to the Windows Azure portal, rather. So here we are. I think by now many of you will be familiar with this. So we've got a ton of stuff on the left side. All we're going to care about right now is mobile services. To create a new mobile service, it's very, very simple. You just go to New, you would choose Compute, Mobile Service, and then Create. And then we could say TechEd is really awesome. And we can choose to use an existing database or a new database. And we'll just choose to put that in the West region. Default database name is fine with me. And I can choose to either create a new database server and enter admin credentials, or I can use an existing one. I'm just going to use an existing one for now. So I'll enter my creds for that. Now, mobile services is actually built on top of Windows Azure websites, and it runs in Node.js. And of course, it can do this because websites can run Node.js. So basically what's happening here is it's spinning up that website and that Node.js runtime. Behind the scenes of that, of course, is that Windows Azure Websites is actually running on cloud services. So there's kind of a lot of stuff going on here to basically create a service that makes it so you can just use that back end and focus on your client application. So it's going to take somewhere between 20 and 40 seconds to really spin this up and finish creating it. Now that my service is created, we'll go ahead and click into that. Now, the first thing you get to is this quick start screen. And here you can choose a platform, and you get the choice between Windows Store, Windows Phone 8, iOS, Android, HTML, JavaScript. Now, one common misconception about using mobile services is that you have to say, pick one of these platforms, and that's all you can use with this mobile service. Today, I'm going to definitely disprove that because we're going to do a few different things here. We're going to start by using HTML, JavaScript application, but then we're going to move over into using an Android application. Later on, we'll just connect without even using one of these platforms here. So we can connect as many applications as we want to the same mobile service. You don't have to create a different one for each platform. So as I mentioned, the whole idea of PhoneGap is you're running an embedded application. And we could always take the iOS SDK, drop that into our application, and then write a JavaScript to Objective-C bridge layer to talk to that. But we already have an HTML JavaScript library that talks to mobile services. So I'm just going to take that and drop that into my PhoneGap application, and it will kind of take care of it for me. So once you pick a platform, you can choose between either connect an existing app or create a new app. Each one of these platforms has a templated quick start, which is a to-do list application. And it's kind of going to be what we're going to be working with today. That way it's very easy for you guys to go home and repeat it later on. If you had an app already that you wanted to drop mobile services into, you just go to connect an existing app, and it would detail the steps of dropping in whatever native SDK or HTML SDK you want to use into your application. For creating a new HTML app, the first step we have to do is say we want to create a to-do item table. The reason you have to tell mobile services to create tables is that when you do that, it actually spins up a REST API around whatever the table name is you created. So right then, it actually spun up the whole REST API around that table so that whenever I hit that REST API, it knows what to do. After that, we'll go ahead and download this. Now, before I can actually run the website locally, I do need to make one change, and that is I need to actually give permissions to run the website. Now that I've done that, we can go ahead and open this up. If I can spell. Yeah, I forgot the really. It's not just awesome, it's really awesome. All right, so like I said, simple to-do to-do list application. Right now, there's nothing there. If I go back to the portal and I go to the data tab, I go to my to-do items, we'll see as soon as it loads that there's no data actually in there yet. So from here, I'm just going to really quickly throw some data in there just so that we can see it work. So this week I had to fly to New Orleans. I had to talk about some mobile services. And I'm still jet lagged, so I really need to get some sleep. So if we go back over to the portal and we refresh, we'll see we've got some data that's been there. Now, at no point in time do you have to tell your mobile service what columns you want created. It uses something called dynamic schematization to look at your data and say, you've sent over a text column. It looks like string data. I'm going to create a varchar column in the database. For the complete column, it looks like a Boolean. I'm going to create a bit column. It does all this for me using that dynamic schematization. And that's something you can turn on and off. So, you're ready to go to production. You don't want to accidentally add new columns. You just turn off dynamic schematization, and it won't do that anymore. So let's...
Just real quick, what's the web server running on your Mac locally?
Just Apache on my Mac.
Part of the Cordova tools when you download it, or did you do that separately?
So Cordova is actually PhoneGap itself, so that's actually running the website. So the question is what web server is running on the Mac, and the Mac is Apache, but Cordova is actually part of PhoneGap, so it's literally running that website in the iOS application, whereas when I went to this site, this is running on my web server locally. So what I'm going to do is I'm going to take this website, and I'm basically going to drop it into my PhoneGap application. Before I do that, we'll take a really quick look at some of the code behind how that application works. So we've got 3 files here. We've got a styles.css, which just has the styles for my application. The index.html, which very simple. The only kind of important parts here are this form, which we use to add the new items, and then this unordered list, which is how we're going to kind of display all of our to-do items. If we go into app.js, the first thing we've got is we instantiate a mobile service client. And we're doing that using the URL of our mobile service and then this application key. If we go over to our portal really quickly, we go to the dashboard, we'll see that we have the URL right here, and then if we go into manage keys, this is where that application key comes in. Basically, no matter which platform or SDK you're using, and when you create a mobile service client, you pass in that application key, and that means that every request to your mobile service will include that application key as a header. This gets into some of the data authorization stuff, which I'll talk about a little bit later. So the second thing we do is we create a to-do item table using that mobile services client, and we specify that it's just going to be named to-do item. One thing I'm going to highlight here is that since JavaScript's a very flexible language, I'm not using any strongly typed objects like we would in maybe in Java or in C#. We're going to look at an example of actually doing that in just a little bit, though. So we got the first method, refresh to-do items. So the first thing we do is create a query, and we do that by calling the where method on the to-do item table. And here we press in the fact, complete is false. So we have a JSON object here that's going to get converted over to an OData filter, which will be sent to my mobile service, which is then converted into a SQL statement to do the select. We call read on the query, and then with the results, we are basically just kind of building a list of list items, and then at the end, we set that to-do items unordered list body to be that list. Get to-do item ID is just some JavaScript to pull out an ID when we've selected or updated an item in the whenever I click the checkbox to say an item's done. Whenever we add an item, we call insert on the to-do item table, and we pass in, again, another JSON object with the text and the complete flag. And then when that gets back, we refresh the items. And then the last 2 things are just update statements, which are relatively easily. Here we're just saying update the item with the text, or here it's update the item with the new complete flag. So this would actually change what the to-do item text is, and this will mark it as complete. And then at the end, this is just saying, hey, refresh all my items. So let's go ahead and actually drop this into our PhoneGap app. So the first thing I want to do is I'm going to copy over my style so it looks right. Next thing I'm going to do is I'm going to create 2 JavaScript files. If we go back over here and look at the index.html, you'll see we're pulling in jQuery and we're pulling in the mobile services JavaScript. One thing that's specific about iOS applications and possibly some other platforms is that you don't want to pull in any code. If you do that, you're not going to make it through certification. It's just a bad idea to try to pull down code and interpret it on the device at runtime. So we're going to go ahead and pull these files down and actually insert them into my application. I'm actually going to do the non-minified version just so we can look at the JavaScript if need be. So while those are pulling down, I'll go ahead and create new files here. So I've got one that I'll put my jQuery in. It's actually quite a bit of JavaScript, so it takes just a second to copy it. So we'll save that, and now we'll create one for our mobile services JavaScript. All right, so that's good. So next thing we're going to do is we'll go back over here, and I'm going to copy over the actual HTML body because I want to display that same to-do list inside my iPhone app. So I'll go over here to my index in my PhoneGap app. Here's what's currently there, which is showing that Cordova, their PhoneGap is ready, or device is ready, rather. We'll just go ahead and replace that with what we pulled from our web project. Then we'll actually add a few, we're going to include those two scripts I just added. So we'll include the jQuery, and we'll include mobile services. So we'll save that. Now the last step that I need to do is I actually need to change what's happening in this JS. So I'm going to get rid of this thing that just says the device is ready once it gets the received event, or once it gets the device ready event. And here I'm going to drop in what I'm doing in that quick start application. So everything inside this function I'm just going to copy into there.
So you're essentially merging your downloaded HTML app into the Cordova format.
Yeah, so the question was, am I essentially just merging the downloaded HTML app into the PhoneGap app? And that's absolutely right. I'm not exactly copy and pasting everything verbatim because you have to put it in the device ready event and stuff like that. But yeah, essentially I'm just taking what was there and putting it where it needs to be inside this app. So now that we've done that, we should be able to run our application. And now it's going to load those tasks, and we're going to say test from iOS. And we'll hit enter. And we see that item here. And now if I go back up to my website, and I get rid of those, and I refresh these, it's got the same data because they're both pointing at the same mobile service. They're both using the same code, but my one app is running in iOS. This app's running on the website. They just kind of work together because they're using the same endpoint. And essentially, PhoneGap works on quite a few platforms. Obviously, iOS, Android, and I'm pretty sure it's got just fine support for Windows Phone and maybe Windows Store. I'm not sure. But essentially, you should be able to drop this application to many different platforms relatively easily. All right. We're going to get into security and a little bit later in the presentation, so yeah, we'll definitely talk about that. So what we really looked at today so far was how you take an application that's connected to mobile services and use that structured storage aspect of it. So when we created our mobile service, it created the database. And then when I told it I wanted a table named studio, it spun up a REST API around that table. It used the dynamic schematization to get the data and basically create all the columns because I don't have to tell it what data types I'm going to send over. When I first created the mobile service, I could actually choose between an existing database or a new one. The reason that happens is that when you create a table, it actually prepends it or sets the schema of that table to be your mobile service. So you could use the same database for as many mobile services as you want, essentially. They're all going to have different names, even if they have, or essentially different names, even if they have the same table name. As far as managing data goes, there's a few options in the portal. You can obviously see the data because we could see it. You can delete rows, and you can truncate all the data. Today, that's it. There'll be more features added in time. But there's also a SQL portal, which is a Silverlight utility linked from the Azure portal, which gives you more of a DBA perspective than to manage your data. There's also the SQL Management Studio, which if you've done any real SQL database work from Windows, you're probably familiar with that tool. It's kind of like the full-blown SQL administration tool. Then, as I mentioned, the REST API that gets spun up when you generate a table, that's what we're using from each of the mobile services SDKs. And you can use that same REST API to kind of do whatever you want. So if you needed to create some sort of an advanced data management system for yourself, you could certainly do that using the REST API. Then there's also command line interface tools, which we'll look at a little bit towards the end of the presentation. that you can use to look at the tables you have, look at the data in them, as well as a ton of other features. Now, as I mentioned before, when you send the data up, mobile services inspects that data and says, oh, it looks like you're trying to save data of this type. I'm going to create a column of this type. This is kind of the mapping it uses right here. It's not a ton of different data types right now, but this covers, the wide bulk of data you might want to save. So we already mentioned the REST API that's generated and the fact that you can turn on and off dynamic schematization. In addition to generating a REST API, mobile services also generate scripts that intercept any requests to your tables. As I mentioned before, mobile services is built off of Node.js, so these are essentially Node-style scripts. Now, if you've done Node.js development, you probably know about NPM, which is the Node Package Manager. You don't have access to that, so you can't access any module you want inside these scripts. But there's a lot of functionality you can process. Some of the modules you get access to inside these scripts are stuff like the request module, so you can make HTTP requests to third-party services, console for doing logging, push for doing push down to to Windows Store, Windows Phone, iOS, or Android applications, tables to a little bit easier access to the tables in your mobile service, MS SQL if you wanted to do custom SQL commands or stored procedures, status codes for, if, let's say you're doing an insert request but you don't want to return a 201, you can use status codes to return a different response. The Azure module can be used to access table and blob storage, as well as, I think, Service Bus. And then there's a few different partners we have in the Windows Azure Store that have modules you can use inside of mobile services. So for Pusher, you can get like WebSocket style communication down to both websites, which is great for the HTML JavaScript library, as well as to actual native iOS, Android, Windows Store, and Windows Phone applications. And then there's SendGrid for sending emails, Twilio for text messages, and I think there's probably a few more. So really quick, let's do a demo, and we're going to look at adding some server-side validation to our data. So we'll go back to the portal, and we'll close that. And I'm going to go to the Data tab, and I'll go into my table. And I'm going to go to the Script tab. Now, right now, all these scripts look pretty identical. The only difference is what the name of the script is, and then potentially the parameters. For the insert method, you've got the JSON item that's getting sent over. I don't know if I mentioned it before, but behind the scenes, whenever you send data up, no matter if you're using the JavaScript SDK, which is actually doing things in JSON, or if you're using a native SDK, it's converting that data to JSON before it sends it to the mobile service. And then when it gets the JSON back from the mobile service, it's going to deserialize it into your strongly typed data if that's what you're doing, or just into your JSON if you're doing the JavaScript. So this item is that JSON property or field. The user object, which right now just has a property that says the user isn't authenticated. A little later on, when we get into security, we'll look at some of the other data that comes in with the user. And then the actual request. So all the scripts right now are just doing request.execute, which says, go ahead and pass this request down to the SQL server. So when I get an insert, just insert the data in the SQL database. If it was a read, which we go over to the read one, it's just going to say, pass my request through to the read script. You'll notice here that the read script has a query instead of an item, because the query is basically the OData filter that's coming through and saying, here are my query parameters. Let's go back to the insert script, though. So what I want to do here is I want to validate the to-do item data and check and see how long the length is. I don't want to save any to-do items that are less than 5 characters. So in here, I'll say if item.text.length is less than 5, request.respond. And here I'm going to use the status codes module. I'm going to say bad request. I'm going to say your to-do item must be at least 5 characters. Otherwise, we're fine to go ahead and process the request, so I'll go ahead and insert the SQL database. So I'll go ahead and save this. Now, because of the way the JavaScript Quick Start application works, when I actually try to do this, it's not going to spit out an error at me because it's not really doing that error checking handling for me, but it's not going to work. So if I do ABC and I hit add, so we never got the response back to say add the item. We got a response back, but again, the JavaScript Quick Start just isn't displaying it like it would be nice to. But it didn't get added here, and if I go to browse the data, it's not going to be here. Now, one difference between the JavaScript SDK and the other SDKs is if you try to, basically, if I was to do the same thing and I was running the iOS Quick Start or the Android Quick Start or one of the Windows Quick Starts, that will actually show an error. So those kind of more appropriately show you that it didn't work. But really quickly, I was able to add data validation on my server side, and then I can decide how I want to handle it on the client side. So next thing we're going to talk about is push notifications. As I mentioned, push notifications are supported for Windows Store, Windows Phone, Android, and iOS applications. If you wanted to do push for a website, there's that integration with Pusher I mentioned. Now, no matter which platform you're using, push notifications pretty much work the same way. You've got a client app that talks to whatever the push provider is and says, hey, I want to get push notifications. Push provider hands back either a channel URI, a token, or a registration ID, depending on your platform, that identifies your device and your application. Your app can then send that token or what have you up to your mobile service, who can then send that to the push provider with a message and say, please push this to this ID. And then the push provider, provided the token you're using or the channel URI is valid, will then send that information down to your application, or it will tell your mobile service, this is invalid, it's expired, whatever the issue is. So the next thing we're going to do is we're actually taking a native Android application, and we're going to add push notifications to that. So I'm going to go back to the portal. I'm going to go back to the Quick Start. And as an example of telling you guys how you don't have to choose or use a different mobile service for each platform, I'm just going to keep going with the same mobile service. I'll go ahead and I'll create a new Android app. I've already got my to-do item table created, and I've already got the developer tools installed, so I can skip those steps and just download my application. So I've already got Eclipse open, and I, of course, forgot to open an emulator, so I'm going to go ahead and do that while we look at the code. So let's go ahead and import the code. I didn't know there were cars behind this wall. That's kind of scary. All right, so let's go ahead and import the code. And if you're doing development with either IntelliJ or Android Studio, which is a new IDE they just announced a few weeks back, it'll import just fine. There is an encoding issue on the source files, which basically just means you have to remove the very first character before it'll import. But other than that, it works just fine. So we'll go ahead and import this project. There we go. And this should be done shortly. Yep, there we go. So the first thing we'll do is we'll run this really quickly, and then we'll kind of walk through the code a little bit. I don't want to spend too much time on it because there's a lot of the code is somewhat similar to what we had in the JavaScript stuff. All right, so again, to-do list application. We've already got our data there because, again, same mobile service, same database. Just to show you guys what I was talking about before, if I try to do that invalid data here, it's actually going to spit out an error like kind of I expect it would in the HTML one. And then if I actually look down at the source of that error, it would come back with the actual error message. So before we actually get into adding the push notifications, let's take a quick look at the code. First thing we'll show is that in the libs folder, we've got the mobile services jar, an HTTP client jar, and a JSON jar. These three are basically what you need to use mobile services from Android. The JSON jar handles doing the actual serialization and deserialization into JSON. HTTP client is there because native Android doesn't support patch requests, so we had to kind of create one, or basically use the Apache one the Apache one that does allow patch requests. And mobile services is obviously the actual mobile services SDK. If we go into the source, so this is what I was talking about when I said how JavaScript uses, is very flexible and just uses JSON data types, whereas our Java application and the Windows C# applications will actually use strongly typed data. And here we've got these attributes that say whenever you serialize or deserialize this data, do it to these field types. And this way it'll match up with what I put in there from my JavaScript app. If I took this off and just had mtext, it would create a brand new column named mtext, and I don't want to do that. Now, if we go to activity, we've got our mobile service client. We've got our mobile service table, which is of the type to-do item. The other SDKs, or the Java SDK, like the other SDKs, also have the ability to do kind of weakly defined data types. So you can basically do a mobile service JSON table, and then you do it's data access more similar to how the JavaScript library does it, because you're not strongly defining the data, you're just using dynamic JSON, essentially. You can use whatever you want in that case. So I'm not going to touch too much on the Android-specific stuff, like how to do a list view or an array adapter. It's kind of similar to the same concept you'd get in iOS. And it's obvious it's Android-specific, and I don't want to bore the people that only want to talk about iOS stuff. So here we've got our mobile service client. We create it using the same URL and the same application key, which again means it's going to get sent over as a header. And down here, we get our to-do item table using the mobile services client and the getTable method. When we want to refresh the items, this is where it's very interesting on how things are very specific to the SDK you're using. In the JSON library, we actually sent over our query as we created our query using JSON. Here we do it using methods, so we call where, and then we say the field complete is equal to the value false. So it's a very method-based query generation handler. If you're doing something in Windows Store or Windows Phone, you're actually going to use LINQ, and that will get converted to your OData filter for you. So the way you query is one of the good examples of how the SDKs for each platform are very specific to that platform. So we create our query. We then have a callback. It basically says, whenever we get a response back, if there was an exception, just show the exception. Otherwise, we have in our adapter, which is basically used to kind of fill our list on the screen, clear that out, and then add each item back in. When we go to add an item, we create our new strongly typed to-do item class. We set its properties and call insert on it. This is relatively similar to what we saw in the JavaScript one. We're just strongly typed data. Updating an item is very similar. We just have that item. We update the complete flag and then call the update on that. So the next thing we're going to do is actually add in push notifications to this application. In order to do that, the first thing we need to do is actually drop in the push notification library for this app, for Android. Now, Android uses, if you're doing kind of Google flavored Android, it uses Google Cloud Messaging, so a GCM library, which we'll just go ahead and pull or grab. So we're just going to drop this into our libs folder, and I'm going to go back in here and make sure it showed up. Great. So now the first thing I'm going to do next is I'm going to go up to the Google API console and get something set up so I can do push notifications. Oop. So I've already got a bunch of stuff in here, but I'm going to go ahead and create a new project, and we'll call it TechEd is really awesome. We'll create our project, and just want to make sure I get everything right. All right, so then in here, we're going to go to Google Cloud Messaging for Android. We're going to turn that on. Then up at the top, we'll go back to API access. And we need to create a new server key. So with GCM, the way push notifications work is that with every request to push notifications, you send over a key, or you basically sign the request with a key, so that when the GCM server gets it, it can look and say, yep, this should go to your applications, it's valid. And that's similar to how it works for Windows Store and Windows Phone. And then for iOS, it's kind of similar, but you do it with a certificate file. So I'm going to take that key that was generated right there. I'm going to go back to the portal. I'm going to go to the push area. And inside here, I'm going to copy my that key into the Google Cloud Message settings. As you can see, above that, we've got settings for APNS and then setting for Windows push. So we'll go ahead and save that. Now, the bulk of the rest of the work I've got to do from the client. And if you've never implemented push notifications on iOS or Android, you may not be aware of how daunting it seems because there's actually quite a bit of setup you have to do. It's all relatively trivial from the mobile services side of view because outside of getting that key in there and then changing my script, there's nothing else I really have to do for my mobile service. So let's go back to here. And the first thing we'll do is open up our manifest file. And I'm going to copy and paste a few things because it's a little complex. So the first thing we're going to do is paste in some permissions. So we've already got the permission that says, hey, I want to use the internet in my application. If I didn't have that, I could never have actually pulled down the to-do items. So the next thing we'll do is I need to set my package here. This is basically just creating a C2D message permission. Now, if you see some C2D and C2DM stuff in here, it's because Google Cloud Messaging used to be known as cloud-to-device messaging. And basically, when they decided to change the name, they just kind of left the stuff behind the scenes the same, so it would backport fine. So we're going to use that permission. We also want to request permission to receive, get account, and then get a wake lock. Essentially, when you get a push notification in Android, you only have a limited amount of time to respond to it. And if you don't respond in that amount of time, you have to have a wake lock in order to basically get permission to take a longer time to respond. Next thing we'll do is paste in a receiver. So in here, we're basically saying, this is my receiver, and essentially what a manifest does is it kind of tells Android, the operating system, what your application is or might be doing. So here we've got a receiver that says, whenever my application, it should be able to send messages, receive messages, as well as registration messages from GCM, and then send data up to GCM. So let me set my app package here. And then the last part I have in here is the service. So what happens here is I'm basically saying this GCM intent service, which is a class I'm going to add in a minute, that's what will handle all the push notification stuff inside my application. So the next thing I'm going to do is I'm going to go to that to-do item class. And since I want to show this relatively easily, what I'm going to do is whenever I save a to-do item from my app, I'm going to include my push ID, which is a registration ID for Android, so I can push back down to my application. So in my to-do item, I'm going to add a registration ID. I've got my JSON, serialized name, just registration, and then I've just got my getters and setters for it. Now I'll go to the to-do activity. I'm going to add a few new private variables here. Specifically, I'm going to add a registration ID and a sender ID. Now the sender ID identifies my application to GCM. So basically, it has to match up to the project I created in the API console. So I'm going to go back in here to the API console, and right up here in the URL structure, that's my sender or my project ID right there. So I'll just paste that in here, and that's good to go. Next thing I need to do is actually register for push notifications. So before I create my mobile service client, I'm going to call GCM register.checkDevice and GCM register.checkManifest. That basically makes sure that my application is set up correctly to receive push. If those weren't true, the application would kind of bar, so it's kind of just a reminder, make sure everything is set correctly. The next thing I do is check the registration ID, which is if I've already registered my application, don't try and register again. If not, then tell my application to register for push notifications. The last thing I need to do in here is whenever I actually add an item, I need to set the registration ID. So here we're just setting that registration ID from the GCM intent service I'm about to create. So we'll go ahead and add a new class. And we'll set the superclass, and oh, good, it worked. All right, so again, this is kind of the class that will handle any messages to or from GCM. It's based off the GCM base intent service, which has 4 methods: on air, on message, on registered, and on registered. If you were building an application, you'd almost certainly want to handle each of these because you'd want to know when, for example, if your app is unregistered, you'd want to tell your server, hey, don't send me any more push notifications, this registration ID is bad. We're only going to implement the on message and on registered today, though. First thing we'll do is add a couple of variables to track the registration ID. One other thing we're doing is we're actually calling in the constructor for my GCM intent service, we're calling the super constructor, so GCM base intent service, and we're passing in a sender ID. That's basically what says, hey, whenever my application registers or does anything, use this sender ID. So the next thing we'll do is we'll implement the on message and on registered. Now, on registered is very simple. It's just setting the registration ID locally. So when we get the registration ID back from GCM, just set it. On message looks pretty complicated, but it's actually quite simple. We're using the notification manager to display a notification. So if you're familiar with Android, when you pull down from the top, that's where you see all your notifications. So all this is doing is saying, hey, I want to build a notification, and I want to put it in the notification manager. Kind of the important part for how our push is working is that this intent is essentially the push notification that comes down from GCM. So inside here, we're using getStringExtra to pull the message out, which is the actual data I'm going to send down. So I'll save that, and that should be fine. The last thing I'm going to do is I'm going to update my insert script on the server side. So I go back to the Data tab. I go into my to-do item. Go to the script. So I'm just going to get rid of all that. Now what I'm going to do is I'm going to execute my request. Now, instead of just executing the request and calling it a day, I've got a success handler. So as soon as I hear back that the request was executed, the data was inserted to the SQL Server, the first thing we do is we respond to our application. So we say, hey, application, we inserted the data, you're good, you don't have to wait for a response anymore. Then after that, we use push.gcm to send a message to the registration ID that came over, and we pass in the text as the payload. Now, this is a method that can be overridden, so you can send in multiple registration. Well, there's actually a send advance that is really the override, but you can send in multiple registration IDs. You can send in different payloads. There's a lot of different options for this. And that's very similar to how it works for iOS and Windows and Windows Store as well, or Windows and Windows Phone as well. I know Windows has like 60 or so different push methods because there's, push text 1 and tile 7 and all sorts of fun stuff. So we'll go ahead and save that. And now if I rerun my application locally, provided it wants to work with push notifications today, go ahead and run this again. All right, so we got our registration ID back right there, I think. Yeah, that's right. So now what we'll do is we'll go ahead and test push notifications. So now when we add this, what we should see is we should see a little push notification guy appear right up here on the top left. So we'll click add. All right, great. So we saw our push notification. So really simple, essentially one line of code on the server side, and we're able to get our push down to our Android application. And this is going to be the same for any of the platforms you got. It's push.apns or push.mpns or push.wns. So really super simple push notifications down to your applications. So the last thing kind of the last big demo we'll talk about is authorization and authentication. So as far as being able to authenticate your users, there's a couple of different built-in providers. So there's Facebook, Twitter, Google, and Microsoft. And they're all equally easy to put into your application. They're all based off OAuth, so you go to the provider and say, I want to authenticate my application with Twitter, for example, and you give them some information like your app's URL, so your mobile services URL. They end up giving you an ID or a key and a secret. You put that into mobile services, and then from your application, you call an authenticate method. It pops up in a login UI, you authenticate, your mobile service and the provider does a little talking back and forth to make sure everything's legit, and they end up handing back something that says, yep, this person's real, they're good to go. So in a second, we'll actually add that. Now, on the flip side of doing user authentication, there's also options for data authorization. So by default, when I create a table, it's set the permissions for each operation are set to anyone with the application key. That basically means that in order to get through to that script, the application key has to be in a header. And that's why, by default, when we create our mobile services client, we pass in the application key. Now, if I didn't even want to require that, I could change my script to the permissions to be everyone, and then anyone that knows the endpoint of my mobile service could hit it and do a read, do a write, whatever that permission is set to. Conversely, if I want to make things more secure, I would set things to only authenticated users. And then at that point, there has to be a valid user token coming across in the header that's been signed by my mobile service that says, yes, this person can actually access my application. And then if I want to be even more secure, I can set things to only scripts and admin, so only another script can access the scripts on that table, or someone with a master key. Now, when I looked earlier on in my keys, there was the application key at the top and then the master key. The master key is something you would probably never want to put in an application you were going to put out publicly, because basically anything you put in an application is no longer secure because it can be decompiled and disassembled. Now, in addition to being able to set those permissions, there's that user object that I mentioned gets sent into each script method. Now, right now, it's just sending over a user.level that says anonymous because I'm not authenticated, I haven't done anything. If I send over the master key, it would actually say I'm an admin. However, what we'll do now is we'll actually add authentication will come over as authenticated. And then once I've actually sent over an authenticated user, I'm also sending over a user ID, which we're going to use in just a second. So let's go ahead and get this set up with Xamarin. So the first thing we're going to do is we'll go over to Xamarin Studio. So if you're doing Xamarin development, so MonoTouch, MonoDroid, this is kind of the IDE you'd run on OS X. If you're doing stuff with Android for MonoDroid, there's actually a plugin. I think it works pretty well with Visual Studio from what I'm told. I haven't played with it very much, but Android you can do straight from Visual Studio. And I don't know if they're working on that from iOS, but I wouldn't be too surprised. So go ahead and look at a new solution. And this is going to be an example of something where I'm kind of building an application without going off of that quick start. We're going to basically do the exact same thing that to-do lists, but I'm just not going to pull the application down. Oops, sorry. Just not going to pull the application down from the portal. So we're going to go into iOS, and we'll do a universal empty project. Just going to put this in here. And we'll name this our TechEd is really awesome. All right, so that's going to create my project. I'm going to go and kill this. So now if I run this right now, it's just going to, well, let me point this at the simulator. So if I run this right now, it's just a blank screen. There's really nothing going on. So the first thing I want to do is kill the application. And then I'm going to go up here to project, and I'm going to go to edit components. I've already pulled down the mobile services component for Mono, but if I hadn't, I could go to get more components, and I could pull it down from the Xamarin Component Store. So I'll close that. I'm going to go to edit components. It's already right here, so I'm going to go ahead and add that to my project. Once I add it to my project, there's a kind of getting started thing. Before I go through that, I'm going to add a couple references. Specifically, I'm going to add the MonoTouch dialog, which is going to make it a little bit easier for me to display some UI in a minute. And then I'm going to go in here and I'm going to add system.runtime.serialization. That's going to help me handle the actual serialization of my data. So the next thing I'll do is I'll take this little getting started string and I'm going to open up my app delegate. And I'm going to say using Microsoft.Windows Azure.mobile services. So the app delegate, if you're not familiar with iOS development, because this is obviously looking a lot more like C# than Objective-C, but essentially the app delegate, it's the same sort of thing as what you get in Objective-C, but it's kind of like the entry point for our application. So finish launching is kind of the first accessible element that I can put code into. So in here, I'm going to drop that code into place. And here I need to actually set my URL, so we'll say TechEd is really awesome. And I'm going to go back into the portal so I can get my application key. And here's that master key I mentioned before. So we got the application key, and we're going to paste that in there. Next thing we're going to do is we will make sure that builds. All right, so we're going to add a new class now that's going to be our to-do item. Now, just like we had in Java and just like we'd have in a Windows Store or Windows Phone application, this is going to be a strongly typed data class. So we'll do to-do item. And then in here, we're first going to say using system.runtime.serialization. That's good. And then we're going to add, we'll get rid of this. We don't need the constructor for now. So we'll add a few different properties. So we'll say public int ID get and set. Then we've got data member. Name equals text. Public string. So basically here I'm just saying I've got a text property, and when I serialize it, it's actually going to serialize down to the text. Just like I was doing in Java, and just like I didn't have to do because I was doing JSON from our JavaScript library. So let me do one more property here. Complete, and we'll set that to bool. And, oh. All right. The next thing we're going to do is we're going to add another class, and this is going to be actually our view controller. So this is how we're actually going to display the information. So call this to-do view controller. And so I don't mess anything up, I'm going to go ahead and copy that code over. Nope. There we go. So we're going to overwrite this. There's a couple different things going on here, but first let's add our using statements. So we'll do Microsoft.Windows Azure.mobile services. And then we need system.threading.tasks. So the first thing we've got here is our mobile service table, to-do item, the to-do item type, and then a scheduler that we use for scheduling. So here, down here, we use the mobile service client we created in the app delegate to get our to-do item table. We create a task scheduler for synchronizing things. Then down here, when the view loads, so essentially kind of this is the first method that's handled once our view is loaded, we call refresh. And here, this is a great example of how we're using a link to actually generate our query. So this is the same thing you'd see in a Windows Store or a Windows Phone application where we use link on the client side that gets converted into OData before it gets sent up to the server, and then it gets converted to SQL on the server side. So we say where our where the complete flag is equal to false, and then once that's false, once we get the response back, we call populate items. In populate items, this is where we're actually creating that UI for us. Now we have one other thing we got to drop in. 1 second. Let's see. So we'll go back to our app delegate, and this is kind of where we specify, say, hey, load my UI. So here we're just saying the root view controller, so kind of like the base view, is going to be this to-do view controller, essentially. So we'll go ahead and build that, and we'll run it. So now we can add stuff from Mono. And that should work, and yep, we got that. So now what we want to do, like I said before, is we're going to add some authentication to our application. Before I do that, what I really want to do, though, is I'm going to go back to the Data tab. I'm going to go into my table. I'm going to go to the permissions. So when I created this table, it was set to anybody with the application key, so all of my applications so far have been able to read it. I'm going to go ahead and change this to only authenticated users, though. Once I save that, if I go back to Xamarin Studio and I'm going to rerun my application, we're not going to be able to get any data because we're no longer, we no longer have permission to see that data. Now again here, what would be ideal is if I put in some code that said, hey, there's a 401, you don't have access. But I'm not going to do that right now because instead I'm just going to actually add the authentication stuff into place. So today we're going to add authentication with Twitter. So I'm going to go to the Twitter dev portal. And I'll go ahead and sign in. And again, it's all pretty much the same no matter which of the providers you end up using. You give them information, they give you information, you put it in your portal. So I'll go up here to my applications and I'm going to say I want to create an application. I'm going to hop over here and grab the URL because I know I'm going to need that. So inside here we specify a name, so TechEd is really awesome. And a description, which we'll just do the same thing. And then we put our website and our callback URL is the same thing. The reason you have to give this to the providers is that the way auth works. What's that? Oh, that's okay. It doesn't really matter. Thank you, though. The reason you have to give it the URL is that the way auth works is it's kind of like your application talks to your website. So in this case, our mobile service talks to their provider. They talk back to you. You talk back to them, and then finally they give you an authentication response. So there's a lot of back and forth on how the OAuth system works. So we put that in there, and then we say, yes, I agree, and we try to enter the CAPTCHA. First try, all right, good. So we get our key and our secret, and this is really what we need out of this. So we'll go back over to our portal, and we'll go to the Identity tab now. So in the Identity tab, obviously, there's basically, again, same information, just for, because everybody has to call things differently, it's named differently for most of these. But we just enter the key and the secret in here. And we save it.
Why would you authenticate against Twitter? Because aren't you looking for your own users? It's not a Twitter app.
So the question is, why would I authenticate against Twitter? Because a lot more people have Twitter logins than have used my app. Now, there's a good question about, whether or not it's better to have custom authentication, which is doable, just not as easy as putting in one of these default providers in, versus using, Facebook, Twitter, something like that.
I guess the thing is authenticating Twitter is almost like the same as anonymous, isn't it? Because you don't know that they're a valid Twitter.
I'm going to guess, though, the point was, you don't really know who they are. You just know they're a valid Twitter user. I'll kind of show you why that we can still use that fact to identify them in just a minute. All right, so we've saved the consumer key and the secret. Now, just like how when I create a table, it spins up a REST API, when I put in that information, it's doing something behind the scenes too. And let me grab my URL and I'll show you. So I'm going to go back to, this is the URL of my mobile service. Right now, if I go there, it's just a placeholder page. Or well-being, it just says, hey, your mobile service is up and running. So if I go to login/Twitter, it's actually going to redirect me to a Twitter login page, and it's going to have, an OAuth token that identifies my application and stuff like that. So this is basically kind of the exact same way we're going to log in from inside our application. So we will return to our code in just a second. So we'll go back in here, we'll kill our application, and we'll go to the view controller. The first thing we're going to do is we're going to get rid of this view-to-load method, and we're going to change it around a little bit. So now what we're going to say is, if our mobile service's current user, so this is the user object, is null, then we know we haven't authenticated yet. Let's go ahead and log in. If it's not null, go ahead and refresh. So now we just need to add that login method. So we'll just put that right here. So the login method is using the mobile service client. It's calling the login async method. And it's basically saying this is the provider I want to log in with. I could get rid of this and I could change it to whichever one of these providers I wanted to. When it gets a response back, it's basically going to pop up an alert that says, hey, you're authenticated, here's your user ID, and then it's going to actually call the refreshing of the items. So let's go ahead and build and run this. So it's going to ask me to authenticate now. So I'll use my account. And since it's going to show you my password, I'll just put it down here and hope that works. All right, cool. I'll just tell it to remember me and I'll authorize the app. I only showed people my password like the first 10 times. All right, so it came back and it said, all right, you're logged in, here's your user ID. Now, the important thing about this, and to his point earlier, is all this tells me is, hey, they're a Twitter user. But I can use that on the server side. So what I really want to do is I want to start, making my app so it's basically a privacy to this. Because right now, anybody that runs this, just like if I run it from any of my applications, they all see the data. So the first thing we're going to do is we'll go back to our portal. We'll go to the data tab. Go into my to-do item script, or my insert script. And we've got this user object here. And now that I'm an authenticated user, not only does it have the level, which is now authenticated, but also has the user ID. So what I can do is, before I actually insert the data, I'm going to set the user ID to be the user ID of the user that's sent in. So I'll save this. And if I go back to my app, I'm going to say, save my user ID. We'll add that item. It's there, okay. Now, if I go to browse the data, remember dynamic schemization is on, so when I sent that in, it sent in the user. It added the user ID into my database. So now I've got this data row right here, which is tied to this user ID. Now, what I want to do next is when I actually pull the items, I want to filter them and say, only show me my items. And I've got two options to do that. If I wanted to, I could go into my code, and where I'm doing the where, right here, I could say, and the user ID is equal to the user ID of my current user object. I can do that because I've got access to the current user, and that would send over the query I want. But the problem is, just like not putting the master key in your application or not thinking that the application key secures your application. Once this application is out in the store, out in the market, wherever, it's relatively trivial to disassemble an application and see what that application key is. There's certainly steps you can take to hide that, obfuscate it, but it's not really secure. So we don't want to trust what comes from the client. Fortunately, since we have that customized server layer, we don't have to do it on the client side. So instead, we'll go to the read script, and inside here we'll say, we'll take the query that we have, and we're going to add a new where clause to it. So now what I've said is whatever the query is sent in, so in this case it's going to be where the items are not, the complete flag is false, add where the user ID is equal to the user ID that's sent in. So now we save this. And now if I kill and run my application again, so it's asking me to authenticate it again because I'm not storing my user data locally. If I stored it locally, I could avoid this process. I'm just not doing it in this demo. But let me log in again. Almost thought you had me. All right, so I'm logged in now, and now it's only going to bring back the ID, the data that's associated with my account. So now everybody that uses this application has their own to-do list. We're not sharing our data anymore. Everybody has to do their own work. And I don't have to use Twitter auth. I could use any of those. I could use all of those. I could put them all in, or I could actually develop custom auth if I wanted to.
How would that work?
It's a little more complicated. If you'd like to come see me afterwards, I'd be happy to kind of walk you through a demo I've got that shows you how to do it.
At a high level, are you using like
So when you use it, so the question is, how, at a high level, how does it work? When you authenticate with one of those providers, essentially what ends up getting handed back to your application is a user token, which is it's basically when you get the data back from whatever the provider is, that's signed and hashed with your master key. That gets sent down to your client, and then that gets sent up to your mobile service with each request. And then your mobile service can say, yes, my master key did sign this. So essentially what you end up doing is you have to do custom auth, you have to end up saving the credentials in your database. So hash the password, save that, and then every time they authenticate, you'd basically create a token that's signed with your master token and hand it back to your application.
It's always based on OAuth. It's a matter of whether you're providing
If you're doing custom auth, it wouldn't be based on OAuth because there isn't some back and forth. It's just sending the data to your server, and then you would create a token to hand back to your application.
What about using the built-in authentication, like iOS has?
Great question. Yeah. Great question. So let me go over to the Android. So the question was, what about using built-in authentication? And really quickly, I'll show you that is, well, I don't have the code for it on here. Let me see if I can do it from here. I think it should work. Let's see, app delegates dot mobile service dot login. I don't think I'm getting IntelliSense. Essentially, though, there's an override of the login method which takes in a OAuth token. So if you do authentication from a native SDK, so for example, you do the authentication in iOS through the built-in Twitter, built-in Facebook stuff, you get back an OAuth token which you can then pass to your mobile service. So you do a login async behind the scenes with that token, and then your mobile service will hand back a signed token that you can still use. So you can definitely do that. You just call a different method to authenticate, and you don't get the UI. Cool. All right, let's get back to the slides then, if I can find them. All right, so the next thing we'll talk about is the command line tools. As I mentioned before, you can use the command line tools to get access to a lot of the data, like the data in your tables. You can pull it down, read it, stuff like that. There's a ton of other stuff you can do with the command line tools. And it's not just specific to mobile services. These command line tools work across a lot of different things in Windows Azure. So we'll look at some of those things you can do right now. So I'll go over here. I'm going to clear that. So first thing we'll do is I'll just, yeah, you guys can see that, right? Maybe, hopefully. Yeah. Okay, so basically if you type Azure, once you've installed this tool, it kind of gives you a list of everything you can do. And we see sites in here for websites. We've got mobile. We've got VMs. We've got account. Tons of different stuff. So we'll do mobile list. And this is going to list out all of my mobile services. Okay, so we see our TechEd is really awesome. Let's do Azure mobile config list. TechEd is really awesome. So this will actually detail some of the configuration options for me. In addition to doing this, I could actually set them. So let's say I had I wanted to test out a mobile service, so I could spin one up using my scripts and then turn it off whenever I wanted to. One of the other cool things I'll do really quickly is I'll just show you that it can do how it does the data. So if I do Azure mobile data read, TechEd is really awesome, and I say my to-do item table, it's actually going to go ahead and read out all the data for my to-do item. So I can relatively easily insert, test data if I want to, pull down the data that's there. A lot of really cool stuff, including the ability to scale your service. So if you need to generate, a tool that you could use to to basically scale up and down your service as needed, you can do that using this this Azure module. And it also works in PowerShell if you're a Windows user. So the last kind of feature I'll kind of show off, but maybe not demo, is the scheduler. So the scheduler does back-end processing, and the way it works is the same scripts that you use on your tables. It's basically the same kind of script, but it's not specific to a table itself. But you can do anything you can do in those other scripts, you can do from this script. You can execute this on its actual schedule, hence the name scheduler, or you can do it on demand. So a lot of cool back-end features you might use for this. So really quickly, I'll walk you through the process of actually getting it set up just so you can see where it's at. So if you go into scheduler, we can create a scheduled job and say my job. I can choose whether to run it on a schedule or on demand. So we'll just say on demand. We'll go in, and right now it's disabled. It's not set up to run on any basis. I can go over to the script area, and this is where I basically just say, this is what I want it to do. And you've got access to the same modules, so the same functionality can be done in here, and then you can just run it. Quite simple. So the last thing we'll look at in the portal are diagnostics, logging, and scaling. So as far as diagnostics go, you get access to the API calls, the CPU time, the data out. As far as logging goes, in addition to being able to use the console module to log stuff, which you can do on your own, mobile services will also log anything that's an error that you're not really catching. So if my script blew up and I wasn't actually logging something as an error, it'll log that for me. As far as scaling goes, you can scale up the size of your mobile service, so whether it's running in shared or reserve mode, and then the number of instances actually running it. And the same thing can be done for your database. You can run your database on a dedicated SQL server. You can scale up the size of your database, all that stuff. So let's go over to the portal and take a look at that really quickly. First thing we'll do is the dashboard. So once we get here, we're going to have this fun little graph here which shows all those stats I mentioned. Obviously, since I just created this mobile service today, there's not a whole lot there. You can also configure your mobile service endpoint for additional monitoring, where you kind of specify more details on what you want to see. If we go to configure, I can change the database of the server I'm running on. This is where I turn on and off dynamic schema. If you're actually, so I use the HTML JavaScript to just drop it into PhoneGap. But if I was actually going to publish that website, which you can do, in order to basically kind of make it work so you're able to access the JavaScript that's hosted by your mobile service in your website hosted somewhere else, you have to enable something called cross-origin resource sharing. So basically, once you push your website somewhere, you just put there the URL of your website here to enable it. And then down here is where you can actually do the monitoring. As far as scaling goes, I think right now I'm running in reserve mode. If you hop over to free, it goes back to a shared mode. And then if you start off in free and you go to reserved, it pops up and says, hey, we're actually going to charge you for this, so are you sure you want to do that? And then once you do that, you can also scale up the number of instances, so when your app gets featured, you're good to go. Down here, you can do the database stuff, and then obviously there's a database area over here where you can see what's on the server and check what the server details are, stuff like that. And then if we go over to logs, I don't know if we really logged in. Okay, we did. So I did have some error because I screwed it. Oh, yeah. So if you notice in my my insert script, I never changed it, so it was always trying to send a push notification. But I was only sending a registration ID when I was running the app from my native Android application. So for all the other requests, there was no registration ID, so it complained because there was, it tried to do a push, but there was no registration ID. So this is an example of where, I'm not necessarily saying, hey, log this, but there it was. And then this one actually was when I actually did send a push notification. But this is where the logging area kind of looks like. All right, so Windows Azure Mobile Service is a backend of the service. It works across many different platforms, including iOS and Android, whether you're doing it natively in PhoneGap or in Xamarin. It gives you access to data storage powered by SQL Database, push notifications, data authorization and user authentication, server-side logic, the ability to scale, logging diagnostics, and then back-end job processing. If you go to windowsazure.com, you can sign up for a free trial account. I'm not sure if they were doing anything else special today or here. If you go to windowsazure.com/mobile, and I'm pretty sure you have to do the www. First or it doesn't resolve for whatever reason. But that'll take you basically to the Mobile Services Dev Center, which has a ton of tutorials, including some of what I walked through today, because I don't think it has much of the PhoneGap or Xamarin stuff yet, but I can certainly point you in the right direction. You can always contact me, and then there's the Windows Azure Training Kit, which also has a ton of stuff on Windows Azure. Obviously, for PhoneGap stuff, phonegap.com, and then for Xamarin, I think it's xamarin.com. Although I would imagine if you went to MonoTouch or MonoDroid, it would probably work as well. Then there are two other sessions today you might want to check out. This afternoon at 1:30, myself and Brady Gass are doing a session on cloud-powered web apps, and I don't remember the rest of the title, but essentially how to connect HTML, JavaScript applications, and ASP.NET into mobile services. So some of what you saw earlier today with me doing the HTML, JS stuff, and then some more advanced stuff, and that's in 265. And then in this same room at 3:15, Nick Harris is doing building real-world apps with mobile services, and I think he's got some fun stuff, including some more advanced authentication stuff, I believe. So if you're interested in that, you might want to check it out. Let's see. Here are some additional resources for stuff. Sounds good. Don't forget to complete an evaluation. Apparently there's stuff you can win, or so I'm told. So do an evaluation, and I don't think that's going to help you because there's a big check through it. So complete your evaluations, please, and I think you can win stuff. That's about it. I'd be happy to answer any questions. Thank you.
Can you talk just real quick about the cost of some of these tools, like the Xamarin tool, for example, and so on?
Yeah, so the question is around the cost of the tools, for like the example of Xamarin. So first of all, I'll touch on PhoneGap because that's the easy one. PhoneGap is free. As far as Xamarin goes, and let me go ahead and pull up the site because I don't want to lie. I thought they did a free offering now. They do? Okay, so there is some free offering for Xamarin. It used to be quite a expensive license fee, but there is some free level of offering for using MonoTouch and MonoDroid now. And then I believe once you have that, like the plugin for Visual Studio is free, and like Xamarin Studio is just part of it that comes with it. I'm not sure what the limitations are of the free offering. I don't know if you... Doesn't have Visual Studio integration? Okay, so I guess with the free one you get Xamarin Studio, but there's at least a free offering to it.
Okay. And the Azure service, I had a free offering too. I was sort of surprised by that. So you're getting a SQL database there.
Yeah, well, there is the SQL database. It depends on if you're in the trial right now. There's a certain amount of free SQL storage you get. Outside the trial, there's still the free level of mobile services, but then there'd be the cost of the SQL database. So I think, for example, if you were just testing around and you had, I think 100 megabyte database costs like $5 a month, but there is still that free level of mobile services. It's basically a usage amount, so you're capped at 165 megabytes of data out per day, but then there's unlimited data in. So if you're testing, developing, very, very low cost. Cool. Thank you.
Have you used Corona Labs instead of Xamarin?
I have not used, the question was, if I used Corona Labs instead of Xamarin. I have not used Corona Labs myself. However, I've got a customer that is using Corona Labs or Corona for a game they're working on, and they didn't run into any issues. They thought they did, but it was just a misunderstanding, and we figured it out.
It does connect to Azure without any issues.
Yep.
Okay. Thank you.
Yeah, no problem. Sure, please do. That way everybody can hear you. Talk loud, and I will repeat you.
Authorization, I guess, from a filtering perspective, but how about authorization based on groups and whatnot like that? How difficult is that in the mobile services world?
Yeah, so the question was around how would you do, role authorization and stuff like that. The answer is that you could build it yourself today, but there's nothing built in for that. There's really nothing to stop you from making quite an advanced system if you want to, and that begs the question of, should I just build this myself, or should I, still use mobile services? There's still a lot of value in what you get out of mobile services, and then you just kind of have to add in some pieces.
Yeah, I see the beauty of mobile services plus some kind of authentication plus a performance-based authorization.
Right, exactly right. And one thing that might be an interesting concept that I just kind of thought about, and it kind of ties into the session I'm doing later today, is that mobile services can always be used in conjunction with other services. So if you were doing your authentication through something like a web API, something like that, something that was kind of more to the style of authentication and role management you wanted to, you can always still connect into and still use the same database for your data storage. So that might be an option if you need to do something kind of more advanced, like a role-based system, and you don't want to figure out how to do it in your scripts.
Okay, thank you.
Yeah.
What's the cost model for push notifications?
Good question. So the question is, what's the cost model for push notifications? Today, and please check with me later because don't quote me on this. Today, I don't think there really is a cost model because I don't think we're tracking push notifications. That may change once we actually go to GA, but it's pretty much bandwidth limited at this point because it is considered part of the data out you get. But outside of that, it's, we're not saying you can only send 10 push notifications a minute or anything like that. You'd be limited by like. A free service can do, I think, 30 requests per second. So you'd be limited in that way, and then you're just limited by bandwidth.
How about with Azure Active Directory authentication?
So the question is, what about using Azure Active Directory authentication? So nothing built into mobile services right now as far as that goes, but there is a partner we've got called Auth0. And if you go to that real world session later today, I'm pretty sure they're giving a demo of using it. And Auth0 is kind of like this great solution for doing anything that's not those built-in providers, because it does, I'm pretty sure it plugs in with AD, it does custom auth, it does, it does quite a few different authentication options that I think would be the thing to look at. Now, I think, or I can imagine we wouldn't at some point in time plug into that. I just don't know what the roadmap for that is.
Okay, thank you.
Yes, no problem. Yes, sir.
Okay, so I started doing a bit of development on the web mobile stuff. In your opinion, what's going to piss me off? What's missing and what's going to piss me off at 2 o'clock in the morning when I'm coding and I find something that's going? Because most of it looks like it's there, but there's always something. So I'm just curious if you found any really substantive development gaps that's on the roadmap to either fix or that is just not there.
Absolutely. So just to repeat the question, it was essentially, if I start using this, what is going to piss me off? And that's relatively easy to answer because we kind of know what we're missing and we're working on it. So, one thing is kind of a more advanced user solution. That's one thing we're working on. More advanced push, because right now you kind of have to track all your push notification stuff. Now, there is notification hubs, which we're expanding support for, and that's kind of going to be, I think we're going to have more advanced push in mobile services eventually, but Notification Hub will kind of do a lot of that work for you if you want it to. Kind of a scripting source control / script debugging, stuff like that. I've got customers with some pretty big scripts because there's no module support, or that too, so like a module support. That's probably going to get to you eventually.
So what are they doing? They're just going to cloud? I mean, on one or two of the website things, I've just ended up having to upgrade it to the cloud offering from websites up on one or two instances because websites were pissing me off.
Sure.
So I was just curious whether or not you basically do the same thing. If you figured on the opposite side, this just gives me a lot of flexibility to just get it done.
Exactly, and that's the idea, is that it's not meant to be this is going to solve all of your problems. Maybe eventually it's going to solve everybody's problem, but today the idea is it's going to solve the majority of your problems in really easy ways and give you the ability to build on top of it. But, there's still going to be edge cases where it's like, it's just either it's really hard to accomplish or it's, you can't really do it. But as I mentioned before, the great thing about mobile services and the fact that it's backed by SQL database is that database is yours. You can connect to it from whatever you want. So if you need to do something that mobile services can't do, there's no reason you can't spin up a website or a cloud service to accomplish that purpose that works in conjunction with your mobile service. But those are some of the issues that I think you probably will run into, and it's stuff that we're definitely invested in making better. Cool. Great.
It just works. I've been able to get a couple of prototypes built relatively quickly.
Awesome.
That's cutting about probably 30% off of my overhead time in terms of administration. Now that it's all interactive with the Visual Studio on the cloud, so kind of shockingly works.
Awesome. Well, if you get a chance to shoot me an email, I'd love to hear more about what you're building with it.
Yeah. If you really want to. The other thing that I can't get quite working right is, and I don't know whether it's a live problem or not, does Windows Live ID support delegated queries? So basically, I have somebody logs into my site, and then they have a repository out on the internet that is also Live ID enabled. So can I then pass their credentials since they're already online? In AD, I can do it pretty damn easily.
Right.
And on my desktop, I can do it pretty damn easily, but Azure keeps throwing me an error that I can't get the context of the logged in Live ID session to delegate the request to basically self-fault.
Right.
Is really it. So it's across all the Microsoft properties.
Yeah. I know there's been an issue related to that, and I'm not sure if that's a specific issue that one of the other guys on the team I'm on was dealing with. If you email me, I can try and get you the best answer I can, because I'm not too knowledgeable about the Live ID issues.
That's it. That was really good. Other than that, everything's worked pretty fine.
Okay.
I had to hard code some of the calls into the other ones while I was prototyping.
Gotcha.
I have to fix it at some point.
Cool. Thank you. Yes, sir.
So my company has its own external SSO based on ping identity. How would I configure that as a authentication provider?
So essentially, I don't even know if are we still being recorded. Are we done? Oh, okay. Well, we can talk as we walk out.